Section 4.5 is going over special systems and also reviewing the methods we've learned for solving systems of equations. Some of these special systems we've already worked with before. The first type of system is one that has one solution, and that's most of the ones we've done before. Say I had a line going here and a line going here. Because they intersect at exactly one point, this has one point. It's normally written as an ordered pair. So maybe -3, 1. I'm just making that up. Okay, we've also seen systems that have no solution. On a graph, they're the parallel lines because they never intersect. So if these two lines were exactly parallel, they would have no solution. The abbreviation for no solution is actually a 0 with a slash in it. We have not solved equations that have no solution before. But if we were solving an equation, the way we would tell it that it had no solution is it would come to a false statement. So algebraically, suppose if I ended up with something like 0 equals 5, this is a false statement. That would tell me that there was no solution to this system. Okay, now we're adding infinite solutions. Okay, the way two lines can have infinite solutions is if I have a line and then I have another line that is exactly on top of it. Because they have infinite points in common, all the points along here, this is considered having infinite solutions. If we were solving something algebraically, the way we would determine that it does have infinite solutions is we would end up with a true statement. If we ended up with something like 0 equals 0, this is a true statement. If I ended up with 10 equals 10, this is also a true statement. Since it's always true, there would be infinite solutions along the lines represented in the system. Okay, now we're just going to do some practice problems, but some of them will have no solution and infinite solutions to see if you can tell the difference. So for each of these, it says solve the system, write the solution as an ordered pair if possible, or indicate no solution or infinite solutions. Okay, the first ones are all using the elimination method, and that's because I want to practice using different methods. Okay, remember, elimination method is when we cancel something. So check to see that things are lined up, the like terms are lined up, and then see if something cancels. Right now I can see the negative x and the positive x are going to cancel, so I'm going to go ahead and continue with my elimination step. Negative x and positive x cancel. 3y plus 2y is 5y. 5. Let's solve for y, and then we'll go back and get x. Okay, now to get x, I could plug it in either of the original equations. Let's do x plus 2y equals -4. So x plus 2 equals -4. Let's solve. -2. X equals -6. So my answer should be written as an ordered pair. It's -6, 1. Okay, let's go ahead and try the next one, also using the elimination method. Remember, first check that the like terms are lined up. Okay, then I want to see if something will cancel, because if it cancels, I can continue to the elimination step. Okay, I can see the x's are going to cancel. So I'm going to go ahead and use the elimination method. Okay, so 2x minus 2x cancels. Okay, now I'm going to go to -3y plus 3y. Okay, -3y plus 3y also cancel. Okay, so what's left on the left side? Nothing. So I'm going to put a 0 equals, and let me add up the right side. 5 plus 20 is 25. Okay, so all my variables canceled. So now I just need to determine this is either going to be no solution or infinite solutions. Does 0 equal to 25? This is a false statement, which means this system is false, which means there's actually no solution. Okay, and no solution is my conclusion or my solution. And remember, if you would like a lazier way to write no solution, you can write 0 with a slash. Okay, let's try some more elimination method. And remember, this is also just to practice the different methods we've learned. Okay, for number 3. Okay, they are lined up. Does anything cancel? Yes, the y's are going to cancel out, so I'm going to go ahead and continue to the elimination step. Okay, 3x plus 3x, since they're both positive, I do add them up. I get 6x minus 2y and positive 2y, since they're opposite signs, they cancel, equals 4 plus 8 is 12. Okay, let me solve this. X is 2, and then I'm going to go ahead and plug that back in so I can get the y value. Either equation's fine. I'll use the second equation just because some of you prefer to avoid negative numbers. So 3x plus 2y equals 8. 3 times 2 is 6. Positive 6 minus 6. Okay, y is 1, and then my answer is an ordered pair. X is 2, y is 1. Okay, let's try number 4. Okay, let's see, are we lined up for the elimination? We are lined up for the elimination method. Now, does anything cancel? The x's do not cancel and the y's do not cancel. So we're going to have to do some extra work to make this system solvable by elimination. Okay, let's see. I'm going to try to figure out this x. Because there's no coefficient, I can kind of think of what I would like to be there. Down here, there's a positive 2x. So if I want this to cancel, I want this to be a negative 2x. So I'm going to multiply the entire first equation by negative 2 in order to make this cancel. Okay, if I multiply all three terms, I get negative 2x. Negative 2 times 2y is negative 4y equals negative 18. Okay, let me rewrite the second equation, and then hopefully the x's cancel now that I've picked the numbers I picked. Okay, now negative 2x and positive 2x do cancel. That's great. Okay, but negative 4y and 4y also cancel because they're opposite signs, so I'm left with 0 on this side. Okay, let me check the right side. Negative 18 and positive 18, that's also 0. Okay, since my variables canceled, this is either a system that has no solution or it has infinite solutions. Okay, does 0 equal 0? This is a true statement, and which means this system is true for all answers. So I'm going to say that this has infinite solutions. It's actually infinite solutions that are along the lines represented, but infinite solutions is a good answer. We're going to do 2 more using the elimination method, and then we're going to practice the substitution method. I know it's a lot, but it's because we're practicing now. We're starting to review. Okay, let's see. The like terms are lined up, so it's set up for elimination. But the x's and the y's, neither one of them cancel right now, so I am going to have to multiply to make them cancel. There's more than one way to do this, as always. Okay, I'm going to think about the y's, I think. Okay, if this is a negative 3y, then I really want this to be a positive 3y, so it will cancel. So right now, it has the wrong sign, so I'm going to change it, and I want it to have a 3, so I'm going to put a negative 3 here. Okay, let me distribute carefully. That's negative 6x. Negative 3 times, well, there's already a minus, so it switches to plus. 3y equals negative 12. Okay, second equation, I kept it the same. Okay, now if I did it right, the y should cancel, which they do. Okay, but the x's also cancel, so I'm left with nothing on the left side. Negative 12 plus 8 is negative 4. Okay, remember this is either no solution or infinite solutions. Does 0 equal negative 4? It does not. This is a false statement, which means this is basically a false system or it doesn't solve. So there's no solution to this system. Or you can do the 0 with the slash to represent empty set or no solution. Okay, let's do one more elimination problem. And again, we're trying to practice this because we're at the end of the chapter. Okay. Are we lined up for elimination? We are lined up for elimination, but nothing cancels right now. And I can't think of something to turn 2 to 5, and I can't think of something to turn 2 to 3. So I'm actually going to have to multiply both equations. Save the best for last. Okay, now you can cancel out the x's or the y's. It does not make a difference. They should give you the same result. I'm going to use the y's just because it has a little bit smaller answers. So I'll just, when I multiply, it'll be a little bit smaller numbers I'm going for. Okay, if you have no idea what to turn the 2 and the 3 into, 2 times 3 is 6. So I'm going to turn them both into 6y's. I will need one to be positive and negative, but I will figure that out later. Okay, so let's look at the first equation. If this is a plus 3y, I'm going to times it by 2, so I can make a 6y. For the second equation, I have a 2y. To get 6y, I'm going to times it by 3. And let me check my signs before I continue. If I do 2 times 3y, I get positive 6y. If I do 3 times minus 2y, I get negative 6y. So they're opposite signs, so I'm going to proceed. 4x plus 6y equals 2. 15x minus 6y equals 36. Okay, let's go ahead and add this up. This is 19x. These cancel, equals 38. Okay, and these are big numbers, but remember, I try to make them come out nicely. So use your calculator if you need to. I got x equals 2. Since I got an answer, I need to plug it back into one of the equations to find the y value. I'm going to use the first one. So 2 times x, what's x? X is 2. Plus 3y equals 1. Okay, I get y equals negative 1, so my ordered pair is 2 comma negative 1. So that's our elimination practice. That's as bad as it's going to get. Let's practice substitution a little bit, just to practice the method, but also to see when we will arrive at no solution or infinite solutions. Okay, substitution method, remember we're looking for either x equals or a y equals equation. So it's a different setup than elimination. So x equals this. So on the first equation where the x is, I'm going to replace the x with the quantity 2y plus 10 in parentheses. So 2, instead of x, I plug in 2y plus 10, or I substitute it. Okay, now I have to solve for y. Let me distribute because there are parentheses. 2 times 2y is 4y. 2 times 10 is 20. Okay, substitution almost always has like terms. So 4y plus 3y is 7y plus 20. So all that work to get y equals negative 3. Okay, I still need to figure out what x is. We can plug it back into either of these equations. I like to plug it in the x equals equation, but now that you're comfortable using the other one, you may prefer the other one. Okay, so x equals 2 times y. What's y? Y is negative 3. So that's negative 6 plus 10, which is 4. So x is 4, y is negative 3. And that's the substitution method. Okay, let's try substitution again. Okay, remember substitution, we're looking for x equals or y equals, so we can plug that expression into the other equation. So because y equals x minus 3, where the y is, I can replace it with parentheses x minus 3. 5x plus 2, pause, plug in x minus 3. Okay, let me bring this down. I'm going to distribute 2 times x is 2x, 2 times 3 is 6. And of course, those like terms, 5x plus 2x is 7x minus 6. And I just spotted a typo, so change the 21 to a 22. And I will fix it before we get to class. Okay, now that it's a 22, this will come out nicer. Okay, I'm going to get x is 4. I need to find y. You can plug it in either equation. But because there's an equation that says y equals, I prefer to plug it in the one that's set up to tell me what y equals. So y equals x. What is x? 4 minus 3. So y equals 1. Okay, 2 more substitutions, and then we've covered the chapter. Okay, substitution, I want x equals or y equals. So I see that x equals 5 minus 3y, so I'm going to plug it in the x for x in the other equation. Let me bring over the plus 6y equals 10. Let's distribute. 2 times 5 is 10. 2 times 6y plus 6y equals 10. Okay, now let's combine these like terms. Negative 6y plus 6y, I mean, those cancel. They're 0. They're gone. Okay, so these cancel because negative 6y plus 6y has nothing. So let's bring down the 10 equals 10. This is either no solution or infinite solutions. Does 10 equal 10? Yeah, that's a true statement. Since it's a true statement, there are infinite solutions and they lie along the equations in the system. Okay, last one. Okay, y equals negative 5x plus 2. Let's plug that in here. 5x plus negative 5x plus 2. And you could do parentheses, but you don't have to because there's no number in front of the y. Equals negative 4. Okay, let's combine our like terms. 5x plus negative 5x. 5x minus 5x cancel. So I bring down positive 2 equals negative 4. Okay, does 2 equal negative 4? No, this is a false system, which means there is no solution.